Good afternoon. So this paper has basically the main things that you should know by the end of this week in math class. So we've got our first skill here is using y equals kx to write an equation of a proportional situation and graph it. So this is really review from last year. We found that a basketball team scored 32 points in 8 minutes. If we are trying to find the unit rate, I would divide them. 32 points divided by 8 minutes gets me 4 points per 1 minute because it's a unit rate. You can put the 1 underneath if you want, but you do not need to. So then to graph this, I would show that on the graph. So after 0 minutes, I know that there's 0 points. We're going to have minutes on the bottom and points on the side. So after 1 minute, we've got 4 points. So that means after 2 minutes, I would have 8 points. And then I would connect with my arrow. So then our equation y equals kx would be y equals 4x. For the next one, a recipe uses 3 cups of flour for every 2 cups of sugar. 3 cups of flour for every 2 cups of sugar. 3 divided by 2 is 1.5. So then our equation, y equals kx, would be y equals 1.5x. So then I've got sugar on the bottom here and flour on the side. So that means I've got this is 1.5 cups of flour for 1 cup of sugar. So for 1 cup of sugar, I would go up to 1.5 cups of flour. And then I know for 2 cups of sugar, that's 3. And that would be what my line looks like. So you want to be able to recognize those points on a graph. Next one, at Wegmans, it costs $10 for 5 pounds of apples. So $10 divided by 5 pounds. 10 divided by 5 is 2, so $2 per 1 pound of apples. So pounds of apples is my per 1 pound, so that's going to be my x-axis. And then on the y-axis is our money. So I'm going to graph that. I'm going to go over to 1 pound up to $2. So that means 2 pounds would cost $4. 3 pounds would cost $6, and so on. In my equation, y equals kx. Here I would put in my unit rate of $2 per pound for x, or for k, and then make sure I write my x. So y equals 2x. So pause there if you need to, otherwise we're gonna keep moving. All right, so the next skill that we've been working on this week is finding the slope between 2 points. So this is on your Delta Math homeworks. We have 2 points and we have to find the slope. So because we don't have a graph to find rise over run, we're gonna use our slope formula, y2 minus y1 over x2 minus x1. So remember, when we fill these in, the x value is first and then the y value. So 19 would be my x1, 3 would be my y1, 20 would be x2, my second x value, and 3 would be y2, the second y value. And then we fill them in. So for y2, I'm going to plug in 3. And then for y1, I'm going to plug in 3. So on the top, I'm going to have 3 minus 3. And then on the bottom, I'm going to subtract my x values. So on the bottom, x2 is 20. So I'm going to fill that in here. And then x1 is 19. So I'm going to have 20 minus 19. And then we simplify the top and simplify the bottom. 3 minus 3 is 0. And then 20 minus 19 is 1. And 0 divided by 1 is 0. So this one would be 0. Real quick, I do want to talk to you about if this were flipped. If I had 1 over 0, and you put this in the calculator, you get a divide by 0 error because you can't divide by 0. So if you are typing it in the calculator and you get the divide by 0 error, that means it's undefined. And there is a button in Delta Math that you can click if you get something like that. Most of the time you'll get a number, but if you do get 0 on the bottom, you can't divide by 0, you'll click undefined. For the next one, I've got my formula. And I'm going to fill this in. Sometimes I like to kind of rewrite the point underneath. I think that helps me keep everything lined up. So on top, I'm going to subtract the y values. So my y values are -7 and 19. So I'm going to subtract those on top. -7 minus -19. And then on the bottom, I'm going to subtract my x values. -2 minus 1. You just want to make sure you go in the same order. Here I did top minus the bottom point, top minus bottom point for the x values as well. So then we type everything in our calculator. -7 minus -19. We get 12. And then on the bottom, -2 minus 1 is -3. And if you type this in the calculator, 12 divided by -3, we get -4. Okay, next one. Subtracting my y values on top, x values on the bottom. I'm going to again rewrite this point over here, 19 comma -2, because that helps me set it up. So on top, I'm going to subtract the y values, 10 minus -2. And then on the bottom, I'm going to subtract the x values. So subtract my x values. I have -11 minus 19. So now we're going to simplify this. 10 minus -2 is a positive 12. And then -11 minus 19 is a -30. So then I type this in the calculator, 12 divided by negative 30. I get the decimal negative 0.4, but for slope, we usually use a fraction, rise over run. So then put this in the calculator, click second PRB. I get negative 2/5. So you want to simplify that 12 over negative 30 to negative 2/5. You can use your calculator if you just type it in and then click second PRB. Pause if you need to. All right, your third skill is to find the slope of a graph. So this is also on your Delta Math. We are going to pick 2 nice points, and then we can use rise over run since we have a graph. So for this first one here, I'm gonna grab 2 nice points. I want it to go perfectly through. So here's the 2 points I'm choosing. They're far away from each other, but that's totally fine. So let's start with our rise. We always read a graph from left to right, so that means I'm going to start on the left-hand side of the graph here. So I'm starting here. My rise, I have to go down to get to the next point. So my rise, I'm going down. That's the negative direction. And I go down 1, 2, 3, 4, 5, 6, 7. So my rise would be a negative 7. So then my run is how far to the right I go. So from where I just left off, I go to the right to get to my next point. 1, 2, 3, 4, 5. And I'm going to the right, so that's the positive direction. So my rise over run would be negative 7 over 5. If you type that in the calculator, you do not get a nice decimal, or you don't get like a nice whole number, so we're just going to leave it negative 7 over 5. So anytime really that you type in a slope and you get a decimal, I would just leave it the fraction that you typed in. So negative 7 over 5, I get a decimal, just going to leave it negative 7 over 5. Pause if you need to. The next one here, rise over run. I'm going to pick some nice points here. So I'm going to start on the left side of my graph. To get from one point to the next, my rise, I have to go up 1 unit. The scale is all ones here, so a box is just 1. So I rise 1, and then I run 1, 2, 3, 4. You can see that that's true. I go up 1, over 1, 2, 3, 4 for the next one as well. So 1 divided by 4, you get a decimal, so we're just going to leave it 1/4. So my slope for this line is 1/4. Notice that this is a much smaller number, so that's why our line is not very steep. When you're ready, flip the page. All right, on the back, our other skill is what we started this week, looking at non-proportional graphs. So we've got 3 examples here of some graphs that are not proportional. And when a graph is not proportional, we want to make sure we use y equals mx plus b. All right, so it says admission at a fair costs $3. Each game played costs $2. So if I'm going to use y equals mx plus b, I need to identify which number is the slope m and which number is my y-intercept b. In class, we talked about how the y-intercept is kind of like an initial cost, initial fee, or starting value. So before I even play any games, I'm paying $3 to go into the fair. That's my admission. My initial fee at the fair is $3. So that's going to be what I choose for b. I'm going to plug it in for b on my equation. And then your slope, that is something that you're doing multiple times. So here it says each game played costs $2. So I could just play one game, or I could play 2 or 3 or 4 or 5 games, however many games I have money for. So because that's something that could happen over and over and over again, that's going to be your slope. It's also your unit rate. If you think back to our unit rates, it's $2 per one game. And your unit rate is also the slope. So 2 ways to think about slope. So I would plug in my equation here, y equals, instead of m, I would fill in 2x. And because this is not proportional, we have to add on $3 for admission. So now to graph this, I'm going to go up to 3. I know that I'm starting at 3 because that is my y-intercept where we cross the y-axis. So I know the y-axis here, I'm going to cross it at 3. That's why I put that point there. Now I need to add on $2 for every one game. So if I play one game and add on $2 more, remember your x-axis here is the games. I play one game, I add on $2 more, now I've spent $5 and played one game. Add on $2 more, play one more game, now I'm at $7. You'll notice my slope here. I rise 2 and I run 1. 2 divided by 1 is 2. So now to graph this, I just connect my points with as good of a line as I can get. You guys won't have a ruler, but I do, so I might as well use it. This is what my line would look like. All right. Number 2 here, an athlete starts a run 1 mile from home and has a pace of 6 miles per hour. So my starting distance is already at 1 mile. That's not something I'm doing multiple times. It's just where I'm starting from, so that's going to be my y-intercept. One mile. So I'm starting at 1 mile. So that's going to be my value for b, 1 mile. I'm going to write down my general equation, mx plus b. And then my slope is what I could do more than once. So I have a pace of 6 miles per hour. Maybe I'm just running for 1 hour. Maybe it's a marathon and I'm running for multiple hours. It could be happening multiple times. So then that is going to be my slope, 6. That's also my unit rate, 6 miles per 1 hour. So that's another indication that it's going to fill in for m, just like we put in the unit rate for k right in front of x. So now I'm going to plug this in. My slope m, 6, I'm going to plug that in for m in my equation. My slope b, or my y-intercept b, I'm going to plug that in for b. So I get 6x plus 1. So this graph is about our distance from home. I'm starting 1 mile from home, and then after 1 hour, I've ran 6 more miles. So then I would be 7 miles from home. Connect your points. I'm going to add an arrow. So I started 1 mile, I then ran 6 more, so I went up 6 to the right 1. Next one. Louis currently owes his older brother $7. So right now he's starting out by owing $7. If you owe money, that means you have negative money. So that means my y-intercept B, where I'm starting, is at -7. Right now I have -$7. Each week, there's a hint that it's a unit rate. Each week, we're going to earn $2 every single week, happening more than once. I'm earning $2 for completing a chore. So that means that will be my slope. I'm going up $2 every week, $2 more every week. So then we'll plug this in our equation, y equals mx plus b. I'll plug in my 2 pieces here. M, the slope, is 2. I get $2 every single week. That's my unit rate. And then B, the y-intercept, my starting value. I am starting by owing $7. So I'm starting at -7. So this would be y equals 2x, and because this is a -7, we can just put -7. You don't need to do plus -7. That's the same as -7. We just want one sign there. So 2x minus 7. So I'm going to start all the way down at -7 because I owe $7 right now. And then every 1 week, I get $2 more. So the y-axis, that's your money. And then your x-axis, that's your weeks. So I'm going to go up $2 1 week later. So now I only owe -$5. I owe $5. I'm going to go up $2 more for 1 week. Now I owe $3. $2 more, 1 more week. Now I only owe $1. $2 more, 1 more week. Now I have $1, that's my own. $2 more, 1 more week. Now I have $3. Not in debt anymore. Up 2 over 1. Up $2 more to the right 1 week. We would connect this with a straight line. That would be my equation. All right, we've got one more skill here. Our solving equations that you guys recently took a quiz on. So we're just going to do 2 practice examples here. I'm going to start with this one here. 3x plus 10 equals -7x plus 15. I see right away that I have x's on both sides of the equation. 3x's on the left side of the equation. -7x is on the right. So I have to do the opposite to get them on the same side. They're on opposite sides. I have to do the opposite. So you could either subtract 3x or plus 7x. I like to add 7x. I like adding better than subtracting, so I'm going to choose that, but it doesn't really matter. -7 plus 7 goes away. Let's see what we got left. 3x plus 7x is 10x. Bring down plus 10 equals, and then on the right, I've just got 15. Now my variable x is here, so I have to get rid of the plain number first. Opposite of a plus 10 is a minus 10. So then I'm going to subtract 10 on both sides. Bring down 10x equals 15 minus 10 is 5. Then I have to get rid of the 10 in front of the x. So I'm going to divide. X equals 5 divided by 10. is 1/2 or 0.5. Pause here if you need to. All right, our last question of the day. One more solving equations. I got some parentheses, so I know I need to distribute 4 times -1.5. I get -6. So this is -6x. Then I have to do 4 times -12. I get -48. I'm going to bring down -8 equals 8x. I'm going to combine my like terms. So I see two plain numbers here right next to each other. So -48 minus 8. I get -56. So this is -6x minus 56 equals 8x. Now my goal is always to get variables on one side, numbers on the other. Right now I only have one number, and it's the -56 that's on the left. So I'm going to move my 6x, -6x, to the right. That way I can get all my variables on the right and my numbers on the left. So the opposite of a -6x is +6x. And I'm going to do that on the right side as well. Bring down -56 equals 8 plus 6 is 14x. And then to get rid of that 14 in front of x, I will divide. So I get x equals whatever -56 divided by 14 is. I get -4. So just a reminder, you got a test coming up. These are the essential skills you should know for that test. That's it for today. As always, if you have any questions, please make sure you come see me. Have a great rest of your day.